Okay, well, moving on to our speakers slot, I'd like to welcome back Ed Brost. Ed has spoken with us. This will be the third or fourth time, and it's always been on the general topic of the Canadian economy and what we're going to do to improve our sustainability, how we can save the value in the oil sands. People probably know that oil and gas exports are by far the biggest single foreign exchange earner for Canada. And if that drops off as different countries try to reach net zero by 2050, we have to do something else with that asset to maintain our foreign exchange earnings. So it's very important. To remind you about Ed's background, he has a long and very distinguished CV here, but I'll just go through a few quick points. He's a PhD and he has a master's in chemical engineering and a Master of Science in environmental and management from Royal Roads in Victoria, which is a fabulous campus site if anybody hasn't been there. He's always worked in the energy sector. He worked at Chalk River Nuclear Labs. He's worked for Ontario Hydro at the Bruce Nuclear Power Development. He's worked at Lambton Generating Station. And a lot of his career was with Shell Canada in Sarnia, but he's also worked with Shell International in Houston, as well as Edmonton and Calgary. And after leaving Shell, he formed a private consulting company. And he was actually is a member of one that I'm a member of as well. He's worked on projects that people have paid him for, but he's also worked on a lot of projects more recently where he is motivated by the interest in the project and where people are not necessarily prepared to pay. And on that basis, he's volunteered a lot of his time with the Bowman Center for Sustainable Energy, where he's done a number of projects in cooperation with Queen's University along the lines of sustainability, energy, and what we can do with the materials if we can't burn them as fuel. So with no more to be said, I'll ask Ed to step up and talk to us about hydrogen, which is a very important topic. Hydrogen, a slam dunk for Sarnia. Ed Brost.
Okay, so I'll share my screen now.
Yep, go ahead.
There, can everybody see that? Uh-oh. Can everybody? Yeah, okay, so good. So let's talk about hydrogen. So this morning, we're going to talk all things hydrogen, and we're going to get it all done in about a half an hour. But before we do, and so we're going to talk about what hydrogen is, how we currently use it, its connection to decarbonization in Canada and globally. How do we get and store hydrogen? And maybe there's a huge and an important role for Sarnia Lambton in this arena. And before we go on, this term here, we've been hearing this for decades. Hydrogen economy. It's sort of like nuclear fusion. It's within the next 10 years, and it never happens. There's something different though this time. The world is beginning to take climate change seriously. And some say failure to decarbonize our economy will turn our planet into a hell, while others still say economic hell will come if we decarbonize. You know what? At this point, it's almost becoming moot. Whether you believe climate change is real or not, right or wrong, the world is going down this path. And I think it was Einstein that says that you either adopt or endorse change or get left behind. And that's one of the things I think Canada has to maybe a little bit concerned about, because the world is moving down this road involving hydrogen. So what is hydrogen? Hydrogen is, first of all, it's the lightest, and probably might insult some of you. You probably know a lot of what I'm going to say today, but I think to be all on the same page, we'll say it anyway. So hydrogen is the lightest element on the periodic chart. It's incredibly reactive, so it almost never exists on its own. It's as a minimum, it's as hydrogen, or H2. But more commonly, it's bonded with other chemical or compounds like carbon. And so it is ubiquitous on the planet, but in bound form. It's used industrially. We have most of the refineries here in Sarnia all use hydrogen for its chemical properties. It's also used as fertilizer, used in a number of industries. So hydrogen is already a well-established chemical in the chemical industry in Canada and globally. But lately, it's becoming more involved in the energy space related to decarbonization of the economy, and that's because hydrogen, although it's the lightest element, it is a colorless, non-toxic gas. When it burns with a colorless, very hot flame. It is hydrogen H2 is flammable, and in the right conditions, it's explosive, and otherwise it's benign. And here's a fun fact: there are no such thing as hydrogen mines. There are no hydrogen wells. It's not. And to get hydrogen, you have to have a lot of energy. It's an energy hog, in one sense. To get energy, you have to put in a lot of. To get hydrogen, you have to put in a lot of energy. And so, how do you make hydrogen? Well, first of all, like I mentioned, you have to start with something that has hydrogen attached to it. For example, and the most common method in the world today is through a process called steam methane reforming. All the 3 refineries here in Sarnia all have their own steam methane reformers. And to make hydrogen using steam, it says methane, but actually there are hydrogen plants that can use propane or like LPGs. But the most common is methane. Methane, recall, is CH4. So there's 4 molecules of hydrogen attached to each carbon molecule. And so when you convert methane into hydrogen, you inject gobs of heat, a pile of water, about 20 tons between 10 to 20 tons of water for every ton of hydrogen you want to make, and you get a byproduct. Because there's carbon, you get CO2. That CO2 is typically vented to the atmosphere. There are a couple of examples in the world today where the carbon is captured. One of them is Shell Refinery in Scotford near Edmonton, Alberta. They capture about 50% of the the CO2 generated or liberated by that hydrogen plant, which is about little over a million tons a year is captured. Another million is still vented. And so that's one of the most common ways. And the other way that is a proven technology, at least, is electrolysis of water. You put in gobs of energy again, but in the form of electricity. You put in water, of course, and the product is going to be hydrogen, and in this case, oxygen. Because there's no carbon involved, there's no CO2 emissions. So the electrolysis of water, unlike steam methane reforming, has no carbon, no CO2 emissions associated with it. Furthermore, if you were able to use low carbon or zero carbon electricity like wind, solar, hydroelectric, nuclear to make the hydrogen, then you have an energy carrier that has no carbon burden associated with it, which is why the world is very interested in carbon for some parts of our economy. It's worth mentioning that there are some other ways to make hydrogen, and a couple of proponents in Alberta have come up with at least lab and small demonstration scale projects where they take methane and strip the hydrogen off the methane, but instead of converting it to CO2, they end up with pure carbon, which could be used in batteries and all kinds of other things. And the proponents for that also would like to have with some justification, consider their hydrogen to be green hydrogen, as is electrolytic hydrogen. Now, I just said hydrogen is colorless. So what's with this about green hydrogen? Well, hydrogen is colorless, but that sounds too simple. And to have a colorless flame, that's too simple. We have to complicate things. It just won't do to have it simple. So people have come up with a color code for hydrogen. And the first one we'll talk about is coal. Now, you can make hydrogen with coal. Coal doesn't have very much, but it's not zero hydrogen associated with it. So by injecting gobs of water and gobs of electricity or heat, you can convert coal, or you can produce CO2 produce hydrogen with coal, and of course produce a huge amount of CO2 while you do it. If you go to the trouble of capturing the CO2, and this is a technology that's kind of proven and certainly available, but very, very expensive. But if you go to the trouble of capturing CO2, you then can promote that black hydrogen, or sometimes it's referred to as brown hydrogen, into blue hydrogen. And so we have a low carbon hydrogen by doing carbon capture and storage of the CO2. Natural gas, as I mentioned, has a lot of hydrogen in terms of molecules, a lot of hydrogen, 4-to-1 to carbon. And so by making hydrogen with natural gas, it's less carbon intense from coal, and so it's called gray hydrogen. And of course, to keep things complicated and confusing as possible, you can promote that hydrogen as well to not green hydrogen, but at least blue hydrogen. And of course, we then get to the green hydrogen scenario where you use some non-emitting CO2 emitting source of energy to make the hydrogen. And of course, if it's electrolytic, certainly a lot of water. I'm not too sure. There's another arrow that's under the pane here that I'm not sure if you all can see it. But anyway, it's an arrow showing emissions. And it shows emissions going down, opposite costs going up. And so you can see that the cheapest hydrogen is coal and natural gas, but the lowest emitting is the green hydrogen. Now, there's a sidebar. There's another color just to be added to this thing. It's called rosy hydrogen, pink hydrogen. We've all heard of institutions, organizations, companies, maybe that kind of oversell what they do in the environmental arena. Maybe they make promises that they can't commit or implement or do not plan to implement. They just say it. It's called greenwashing. Well, the coin's been flipped. There are proponents, there are people who oppose this move to hydrogen for a variety of reasons, being expensive, it's going to take a long time. And so the picture I'm painting today is referred to as rosy hydrogen. It's not part of the official palette, but it is out there, and you may come across it when you read about a hydrogen economy. So now that we've made rosy or made hydrogen successfully, how do we what do we do with it? Uh-oh. There we go. As I mentioned, there are existing industrial users, and if we wanted to convert them to green hydrogen, we have a problem, and that's the price. There's a price issue. As shown on the earlier slide, the green hydrogen is quite a bit more expensive, about 5 times as expensive as hydrogen made by natural gas. And so we need to somehow deal with that barrier. And there's a couple of ways, carbon taxes being one. Wood Mackenzie and Bloomberg and that ilk are saying that we'll have price parity between electrolytic hydrogen and methane or steam methane reformer hydrogen by about the end of this decade, by around 2030. And why is that going to happen? Well, continued decline in renewable energy costs, solar and wind in particular, improvements in electrolyzer technology, and economies of scale. And so I'm not an economist, but that's what's being forecast. And so if you were going to develop a hydrogen economy in an economy which doesn't depend on hydrogen, when do you think you might start working that? Well, I'm going to say about now. It'll take 10 years, and if we take a bet that the prices, or for whatever other reason, government incentives, whatever, is that this is going to take off in the next decade, now would be a good time to get started. How would you use this hydrogen in the future? Well, one would be transportation fuels, chemical industry applications that currently do not use hydrogen. For example, making steel. Coal is used to make steel today. And one of them, though, a big one, is electricity generation. Now, that's why Mickey Mouse is on the screen here, because it sounds goofy, not Mickey, goofy, Why would you make electricity? Take electricity, go to all the trouble of transmitting it to an electrolyzer, make the hydrogen, do something with the hydrogen in the meantime, and then turn it back into electricity. Well, the reason for that, the opportunity that is there has to do with how we generate electricity. It's used in real time. And there are times of day, as we all know, electricity is more expensive in the daytime because McDonald's and everybody is open. And at night, there's not so much use. So we have surplus and lower cost electricity at night. So if we could take advantage of that diurnal swing, there might be some opportunity to make money. It gets better. There's also seasonal changes in electricity demand and which can affect price. We use a lot more electricity in August with the air conditioners and whatever in the summer, and then of course in the heating seasons in the winter. And so the energy supply, the electricity supply system, generation, transmission, distribution, has to be able to meet these peaks all the time. And so there's idle equipment sitting around for most of the year that could be used. And if we could take that cheap electricity because of idle equipment, we can maybe make some money. There's more. There are power quality issues. We won't get into what that means exactly, but you can get a premium if you can sell high quality power. And the response time is another feature that has, if you can bring the power on quickly, there's a premium that could be captured for that. And for example, everybody comes home and plugs in their electric car at 7:30. You want to be able to ramp up production really quickly to supply that demand. So there are opportunities to make money here. There's a byproduct here, oxygen, and oxygen is quite a valuable product. So when you're looking at the economics of what are you going to do with green and blue hydrogen, we also have an opportunity to sell the oxygen. Now, I talked about making, producing the hydrogen at night or when power prices are low, and then selling it when power prices are high. Well, that implies storage. So how do you store hydrogen? Today, hydrogen is stored in specially designed vessels, tanks, if you like. They are expensive. The hydrogen is stored at very high pressures, and there's also the option of cooling the hydrogen to, if you really have money and you want to spend a lot of money, you could cool it in a cryogenic process to form liquid hydrogen. We see that in aerospace. It's a fuel for rockets. And so that's sounding kind of impractical on a massive scale. Can you imagine a tank farm like you see in the local refineries, full of specialized hydrogen storage vessels, covering tens of acres? And I don't know, I find that hard to imagine. But there's another option, and that's geologic storage. As we all know, below us, about I think a few hundred meters, are very thick salt veins. These salt veins stretch from Windsor to Goderich, and what you don't have if you have salt? Water. This is a very dry area, and as you know, most of you, I'm sure, are familiar that we have salt caverns. You can wash these, inject water into these salt veins and produce a cavern. These salt caverns are in use today. I think there's more than 100 of them between here and Goderich. They store everything. They're used to store everything from natural gas, LPGs like propane, butane, gasoline, even crude oil is stored in them. And they've been there for notionally close to 100 years, some of them. It's a proven technology. It's safe, and it could be used to store hydrogen. Yes. And this isn't an idea that the Bowman Center has come up with. Not at all. There are not very many, but there are places in the world where people are actually storing hydrogen in salt caverns. There's one in Colorado, at least one, and a couple in one of the Scandinavian countries in Europe. So you have to ask the question: if there's going to be a hydrogen economy, and Sarnia-Lambton knows all about salt caverns, we also know a lot about making hydrogen. Why not in Sarnia-Lambton? So just to recap for a bit, we've talked about making hydrogen. We've talked about potentially existing and new markets. If only we could store the hydrogen And if we have the smarts to store the hydrogen, we could then turn it back into the closest existing market would be to make electricity out of it again, but in opportune times. And so what I've just described to you is in functional terms anyway, a battery, a large battery, a battery capable of storing hundreds of megawatts. In a modest size well, a 30,000 cubic meter well could store 800 megawatts or megawatt hours of electricity. And so this is in terms of enabling wind and solar, has a huge potential, I think. So to visualize this, voila, here we have it. This is what it might look like. We have a off-peak power at low prices, without emissions, goes to this Sarnia Lantern as a load. We take off some of that extra electricity, we send it to an electrolyzer where we convert it into hydrogen. We inject a bunch of water. The electricity comes in from the grid. I don't show it here, but there's valuable oxygen coming out of here. The hydrogen goes to a compressor because you need to force it underground, fairly high pressure, into the salt cavern where it displaces brine. That's why it's under pressure. And then when we want the hydrogen later on demand, we can run the hydrogen back up through the same compressor running backwards. We can generate some electricity and recover some energy losses there. Goes to a fuel cell to produce electricity. Now, there are technologies, solid oxide fuel cells in particular, that can do both. It's the same device, you just run it backwards. In any case, we produce electricity, goes back to the grid. So that's our Sarnia Lantern hydrogen storage battery. If we generate electricity in the daytime and it's not, and there's more than what our we need, we could even sell it. So now that we have this energy battery, we can go back to the future and talk a little bit more about what do you do with hydrogen. So as I mentioned, it could be, if we could build this thing, an enabler, enable the future and some sectors of the economy as they try to decarbonize. If the production cost declines as forecast down to parity with natural gas, we could have clean, green hydrogen that is affordable. That can be achieved, as I said, through efficiencies and economies of scale, but it could also through government mandates, either ordered or indirectly through carbon taxes, because one of the reasons why methane or steam methane reforming is cheaper than electrolytic hydrogen is because they're able to externalize some of those costs. Externalize means that they emit the CO2 into the atmosphere. If they were carbon taxes are a pressure to internalize those costs. The other way to do it, of course, is subsidies. This hydrogen can be used to decarbonize elements of the economy that are very difficult. The electric airplanes are probably in the future within this decade for short-haul flights. Are companies like Boeing and Jet that were spending gobs of money betting on where batteries will be in a few years. Not where they are today, but where they are in a few years. But it's hard to imagine transoceanic air cargo planes flying on batteries across the oceans. Maybe it'll happen, but for me, it's hard to imagine, and others as well. That's why people are considering hydrogen as an aviation fuel. And how about container ships going from Vancouver back and forth to China? It's hard to imagine that being done on a battery with a battery. So one option would be to decarbonize that industry as hydrogen as a fuel. Even long haul trucking is that's up in hydrogen for cars is unlikely. Batteries, I think most people think of that battle, but for a railroad locomotive, the cranes that are sitting outside my house here working on the lake, hard to imagine them running on batteries. So those difficult decarbonized sectors have potential with hydrogen, which is why countries around the world are looking at hydrogen. And again, what are we going to do with it? Don't forget this hydrogen, this oxygen byproduct, this pure oxygen, and it's valuable. So developing hydrogen strategies seems to be all the rage these days. people around almost 100 countries, well, say jurisdictions around the world have already developed and some of them are implementing hydrogen strategies. Canada's a little bit behind. Late last year, Alberta published their hydrogen strategy, which is called Natural Gas Vision and Strategy. It's all about blue hydrogen and how Alberta, because of its natural gas resources, could be an exporter of blue hydrogen to their own economy and for export market. Late last fall, Ontario released a discussion paper, which was released through their environmental registry for public comment. The Bowman Centre commented on it as well as SLEP. But last December, like 3 months ago, the federal government published their national strategy. And all of these, by the way, documents refer to the color palette that I talked about earlier. And so countries, European Union, China, Russia, the U.S. now that Biden's they're all embarking on this hydrogen economy. So I think it's important that Canada pay attention to this. We seem to be doing it at a federal and at least several of the provinces, which means that there could be money available for credible hydrogen projects. Now, this federal plan talks a little bit about something called regional hydrogen hubs, and that the intent is to develop some of these hubs across Canada. They don't say a whole lot about it, about what these hubs might look like, and so I've taken the liberty of coming up with what would help qualify a region or a community to be selected as a regional hub, or at least be considered. And so this is my list. We need a receptive community. Well, Sarnia-Lambton is a host to heavy industry, and I think it's fair to say that, you know, as long as the technical and process safety challenges are addressed, and I think that would be a no-brainer, that Sarnia-Lambton would be a receptive community. The Bowman Center's had some discussions with one of the First Nations communities in our region, and they are open to the idea. If this thing were to go properly, they might even be seen as being a partner. As I mentioned, you need a lot of water. We have lots of water. Access to skilled labor market in spades. Access to potential heavy industrial customers. We have 3 refineries here that use a lot of hydrogen. Access to underutilized green and low carbon electricity. Well, Sarnia-Lambton, like most of Ontario, scores on that one. Experience with grid scale electricity production. We have we have a couple of generating stations in this region. One of them, of course, is decommissioned, but we know about how to make large amounts of electricity here. We're probably world experts on salt caverns, both designing, solution mining, and operating salt caverns safely. Experience in designing hydrogen production. We have at least three hydrogen plants in this region. We know how to make gray hydrogen already, which means we know how to safely handle hydrogen at pressure. If this is going to be a new industry in Canada, starting hopefully here in Sarnia, then we need to be able to have the capacity to develop and deliver training for these new skills. A project like this will involve social and environmental health impact assessments, and it would be good to have local consultants who know this community. We have that. There may be others. This is the list I came up with, and a big one, an enabler, is the capacity for geologic bulk storage, which we talk about as salt caverns. So, got to ask a question. It's too bad we're not all in person. We could, have a show of hands. But I'm just wondering, does anyone recognize a region in Canada, somewhere in Canada, that has some of these prerequisites? Anybody? Any guesses? Anyone? Anywhere? It's hard to imagine that anybody has. Sarnia-Lambton. We have, we have every one of those prerequisites. So what's happening? We recognize this now for a little over a year. The Bowman Centre developed and commissioned a study with Queen's University. That study is underway. It'll be completed by the end of, or say early first quarter of this year. They've been working on it now for almost a year, well, since last fall. And it'll be a somewhat detailed engineering and economic assessment of building a notionally 30,000 cubic meter hydrogen storage facility here in Sarnia-Lambton, which of course includes electrolyzer and generation capacity. And that report, like I said, will be available later this year in a couple of months. And we intend to use that as a launching pad or a foundation to push and press governments, provincial, federal, and to try to show that this region is like it's not a candidate. Like this is a slam dunk for Sarnia, it seems to me. And it's really, we have everything. And if you think the hydrogen economy might take place, and if you think it's going to happen in Canada, I think we should all be working towards trying to drive it to steel on the ground and jobs in Sarnia, and have Sarnia be a demonstration facility for all of Canada. So that's what I have to say. We've talked about hydrogen, what it is, current uses for hydrogen, connection to decarbonization. And if you agree with what I've said, or you think it might be the right path, I encourage you to talk to Marilyn and Bob and others. If you have any ideas on how to push this idea forward, the Bowman Center would be glad to hear your ideas. And so if you have any questions, I'll be glad to take them.
Ed, what we normally do is we've got a bunch of questions on the chat line. I'll run down and try to summarize them a little bit. It saves you having to read them back. Is that okay? Or, yeah.
Shall I stop sharing?
No, I can just whip down through. Alan McEwen is asking, Airbus is testing several prototype aircraft fueled by hydrogen. Is this a way for the airline industry to eliminate its large carbon footprint and do it economically? So it's airlines. Well,
yeah, I did mention that in one or two of my, at least one of the slides. It's a bet. You know, all these things are a bet. You're betting on the future. And the airline industry has a problem. They're looking at not only batteries, like there's I forgot the name of the company in Vancouver, in Victoria, that has an air taxi, and they've already demonstrated an air taxi a year ago, I think, John. And so there is this battery competition. Like I said, I think it's batteries of one for short range vehicles and perhaps planes. There's a couple of companies that sell battery powered electric trainer aircraft for people who want to learn to fly. Transit or long distance air travel, though, seems to me, and I'm no expert, but it seems to me a bit of a stretch for batteries. Doesn't matter how much you increase the energy density and lower the cost. It's hard to imagine that the technology will ever get there. And so certainly hydrogen and people with a lot of money and really smart people are looking at hydrogen. Well, that's all I can really say, Alan, is yeah, I've observed the same thing you have.
Thank you, Ed. I guess I have to throw this one in. The EU and the UK are more interested in using hydrogen for space heating and process heating, not as a source of electricity, because electricity to hydrogen and back to electricity is very thermodynamically inefficient, whatever you do with it. So is this an option for Canada? What you may know that the city of Leeds in the UK, as a test site, is being converted back to burning hydrogen for heating homes and industrial space heating, because if you use that route to heat rather than to electricity, it's much more thermodynamically efficient.
Well, efficiency is exactly the key word. You're right, John. And even a fuel cells is, notionally at 50% or so efficient. And so the cycle efficiency, starting with power off the grid, never mind upstream of the distribution system, is down to about 30% by the time you get back to electricity. And so space heating or industrial heating, using the hydrogen as a heat source will be much, much more efficient. Could it be applied in Sarnia? Well, it depends on, economics and the development of infrastructure to deliver the hydrogen, people changing their furnaces or industries changing their industrial furnaces. It really comes down to resolve. How bad do we want to do it? How visionary and courageous are our leaders to encourage something like this, thinking not about where we are today, but where we will be in the future. Like Wayne Gretzky said, we need to look where the puck is going to be, not where it is today. And so I don't know how to answer your question, John. I think it is possible. It depends on how bad we want it.
Okay. I'll combine a couple of questions. John Timar and Stan Martin have got questions about the combustion of hydrogen. Do you not think that it will generate a lot of NOx? High temperature combustion generates NOx. And what about the water vapor that's produced when you burn hydrogen? Because you end up with water vapor.
Yeah, there's two parts to that, so let's unpack it. Water vapor, I think I'm more personally concerned about than the NOx. First of all, if you use a fuel cell or some form of fuel cell technology, there is no NOx. And the fuel cells, solid oxide fuel cells operate at about 800 degrees C, no NOx. And so that is high quality heat. You could use it for space heating if you like, or other purposes. Excuse me, I think a normal proton exchange membrane hydrogen, John, you might know better than I think they operate around 50 or 60 degrees, so you do have low-grade heat there. If you burn hydrogen, as I mentioned earlier, and somebody pointed out, it burns very, very hot. So if you don't keep that temperature, the flame temperature under control, yeah, you're going to generate a lot of NOx. And so now there is a technology, oxygen, combusting it in oxygen. Don't use air, like what happens in a gas fire is another way around that. But anyway, the technology exists. Can you afford it? Water vapor, though, to my mind, I'm personally, especially for aviation, my understanding is water vapor high in the atmosphere is more detrimental, more CO2, more impactful on climate change than down lower where it tends to rain. And so having the entire global aviation industry operating at 30 to 50,000 feet above ground and spewing tons and tons of water into the atmosphere up there needs to be assessed. I personally think that really has to be looked at. If we were to convert everybody's furnace and heavy duty trucks, there's going to be a lot of water put into the air that isn't there now. And I think that is an area that needs to be understood. So no solution to any problem is perfect, but you can approach perfection or optimum by at least understanding what the issues are. And that is an area, whoever asked the question, that I agree really needs to be looked at.
Thank you. Jim Donahue points out that the automotive industry is embracing battery power. You may have seen the Ford adverts in the last few weeks, which is mainly aimed at conventional batteries, lithium-ion type battery vehicles. But he asks, is there an automotive market for hydrogen? I noted that not Honda, but Toyota is advertising its hydrogen-fueled vehicles in Canada already.
Yeah, I would say there's a VHS beta little spat going on between hydrogen and batteries, and right now batteries seem to be winning. The infrastructure is already pretty well established. Never mind the technology that's in the cars. But Toyota and BMW, most car companies, Toyota's the most vociferous about it though, have hydrogen fuel cell technology research and development underway. So the war isn't over. Nobody's surrendered here. Yeah, Elon Musk just calls it outright idiocy because of the efficiency of a hydrogen, like the cycle efficiency of a hydrogen fuel cell vehicle. And so, no, I'd say this electrification of transport, even at the domestic or light duty vehicle market, isn't over. Like I said, I think it's heavily favoring batteries today, but there are other battery chemistries too that have to be explored. Aluminum air batteries are an option where these aluminum air battery technology exists today to give a car well over 1,000 kilometers of range, and then you go to some place and they replace the anode in your vehicle. That technology is not dead. It's coming. And so I think the way I think we all live in a really exciting time. It's scary and it's exciting, challenging and opportunistic, and we're watching it all unfold in front of us. I don't know the answer to your question, Alan, but 10 years from now, the world, I think, is going to look a whole lot different in pretty much all aspects of the energy component of our economy.
Thank you, Ed. Yeah, Paul Woolley makes the point that we have a large site, Courtright Hydro. It's there right now. It's got switch yards and various other pieces of infrastructure that you might need. Is this a possible site for this hub that you've talked about for Sarnia to take electrolysis and so on?
Yeah, this whole idea that I presented to you here this morning is embryonic. It's conceptual in nature. And as long as the people who are decommissioning the Lambton site don't go to the trouble of decommissioning the switchyard and its interconnects to the grid, it seems like a no-brainer site to me. You could, I talked to Alberta, Ministry of the Environment and Climate Change when it was that, now it's Ministry of Environment and Parks and Recreation, about this idea 2 years ago, or maybe, yeah, about 2 years ago. And they told me at that time that solution mining a new well would not be a problem. There are, in fact, procedures in place that allow you to get a permit and wash out the well and dispose of the product brine. So we could, or you could repurpose an existing well, but then you'd have to have some infrastructure connecting to a well, and the economics would have to favor hydrogen for the person or institution that owns the well. But you could either solution mine a new well right at the Lambton generation site or near it, use the existing transformers, stations and connections, and save a whole pile of money. The plant that we're looking at with Queens would be notionally 100 megawatts, like a 100 megawatt generation capacity, so nothing compared to what Lambton was at 2,000 megawatts. And Paul, you would know better than I do, is there unlimited turn down on a transformer station? We just use small part of that system and save all the capital? But yeah, I think the short answer to your question, coming from somebody who really doesn't know that industry well, power, electricity, transmission, seems like it is. Seems like it would be, Paul.
Penny Gladwish points out that we used to hear an awful lot about the Darling of Vancouver being Ballard Power, but we don't hear much about them now. What is the story with Ballard? Going
concern. They are building and selling, like they're mostly selling fuel cells for buses and medium duty trucks. And so my understanding is they went through a bit of a slump, and I think they're kind of on their way back, but that's easy enough to check out.
Who owns them, Ed?
Pardon me?
Do you know who owns Ballard? Were they bought out by Elon Musk or somebody?
No, I can't imagine. Elon Musk is rosy hydrogen guy.
Okay. David McGinn asks a very pertinent question, and that is, what are our MP and MPPs? What's their position on Sarnia as a hydrogen hub? Marilyn and Bob.
Well, I can't say I haven't talked to either one of them. But because the Ontario government's discussion paper, I did read through it, made comments on it, and it was pretty good. I think they're kind of serious. I think they're seriously interested in getting federal money. And so I think, Bob being a conservative or a party guy, and that's a conservative document, I'm guessing that, he would be in support of it. I don't know Marilyn's stance. Of course, politically, she's not going to want to. I don't want to say. I really don't want to say, because I'd just be speculating.
I guess we're running out of time. We've got a little bit of time for a few more questions. Brian Ray wonders whether it would be practical or more practical to electrolyze the hydrogen at the base of the wind turbines. Does Lambton County have pipeline infrastructure to collect and transport the hydrogen if we were to do that? Does it fit with the natural gas pipelines? And of course, this leads into power to gas, where you store the hydrogen in the natural gas pipelines, perhaps. I'd like to say a few words about that, because that is the alternative to brine cavity storage, is power to gas, inject some hydrogen, and dilute the natural gas with it?
Yeah. So a couple of things. First of all, you could, the technology is there. You could put the electrolyzer at the base of or in a wind farm if you like. One of the things I didn't mention on my list of prerequisites would be the ability to move hydrogen. Suppose we do get moved to a marine shipping business that uses hydrogen as fuel. It wouldn't be for Purdy's boats and maybe the Duke d'Orleans, but we have transoceanic ships that go by here. We could be a hydrogen fueling station for marine applications. Even these 1,000-footers could be running on hydrogen instead of marine fuel. It would be more difficult to do that if the electrolyzer was over in forest. And so I think one of the advantages of having it in the Sarnia-Lambton region is being able to access, not now, but where the puck is going to be, fueling facilities or docks. And we have several of them here in Sarnia. One of them, of course, Lambton Generating Station. We talked about the transmission of the electrical infrastructure there. There's also a huge dock that could be used as a fueling station for hydrogen-powered vessels. Another advantage of building it in the Sarnia region would be potential industrial customers who have been incented either through carbon taxes or cash in hand or whatever to shut down their gray hydrogen plants and buy green hydrogen from us. It would be more difficult, much more expensive if the electrolytic hydrogen was being manufactured 50 kilometers from here. Space heating, again, first of all, we're not building a hydrogen plant. Our concept at this point is not to build a hydrogen storage facility for the world. It's to demonstrate the technology. A small 100 megawatt plant being able to store something like 800 megawatt hours of electricity, which means you could run this system for 8 hours. And that's after taking into account the efficiencies in a well that is on the small, it's median of all the wells in the region. That's where the 30,000 came from. And so I think the market, because of the marketing potential for Sarnia-Lambton, we're better to build this facility somewhere inside of Sarnia-Lambton rather than more remotely. And as far as hydrogen and gas, you're right, John. I think that's part of the potential market. As you know, though, there are serious limitations around just how much hydrogen you can inject into natural gas. Our students have looked at that, by the way, and found when you think about it, it's not all that surprising. But it turns out that the energy content, the heating value of hydrogen diluted natural gas is lower than pure natural gas. And that's because of the density difference in hydrogen and methane.
Okay.
Anyway,
Sorry, go on.
Pardon? I was just going to say, these are all answers to the question of could we locate it at the base of the wind turbine? The answer is yes, we could. But I think that there are, if you look at where the puck might be, it would be better to build it in the region here.
To centralize it, yeah. Okay, Sharon makes the point that Chicago Transit has been running hydrogen-powered buses safely for 25 years. And we all know that Cutric in Canada offers analysis of hydrogen versus electric versus diesel buses. And there are hydrogen buses running in Canada as well. Would you like to just say very briefly where the bus situation is?
Yeah, I'll say it this way, though. As fast as the general public is transitioning to electric vehicles, mainly batteries, I personally think the huge impact is going to come from medium-duty trucks, delivery trucks, UPS, Loomis, that crowd are all announced. Amazon has ordered 10,000, not 1,000, 10,000 electric delivery vans to start delivery and they'll be starting delivery late this year. Buses, you may know this, John. I'm sure you know that Canada is host to 3 electric bus manufacturers. They're in business selling buses and drivetrains in Canada and to the world. And so in hydrogen, like I said, that battle's not over. I kind of think short haul, like a municipal small city buses like Sarnia probably will end up being driven by batteries. But that's just my bias. But like a Greyhound bus that's going to take people on a tour from Sarnia to Vancouver, good chance, especially if the hydrogen infrastructure, like filling stations, are developed. I think there's a good chance of, one of the big problems is if you have electric cars is heating the thing. Heating and air conditioning to a lesser extent is a real burden on the battery. And if you have a hydrogen fuel bus, you're going to end up with a whole pile of waste heat as you do in a conventional petroleum fueled car. Don't forget, about 80% of the energy that you paid for to put in the tank ends up as heat. And that's why you don't grab the muffler. That hot muffler was paid for by you, and that's why there's this huge radiator sitting in the front of the thing. So heating a bus traveling in the wintertime from here to Vancouver would be much more straightforward if it were fueled by hydrogen.
Yeah, thank you, Ed. Great answers. I'd like to call on Paul Woolley to offer a vote of thanks for your efforts. Very nice presentation, lovely slides. So, Paul.
Hi, Ed. I've known you for quite a number of years, both as a friend and as a co-worker in Blue Green Innovation Group, along with John. We seem to be overloaded with the Quanians. You'll have to join our club. And I've known you.
Morning, it's Debbie. How are you?
Oh, hi, Debbie. I'm just in a Zoom meeting, but
somebody's
Sorry.
Bill.
No, thank you very much indeed.
Anyways,
Okay, bye-bye.
so I've known your talents as both an engineer and a scientist. And I know that one of the things is that you always are very good at thinking through any task and studying and applying rational and critical thinking to whatever it is. And you do that with both passion and excitement. And I think I've heard today, as I think we've all heard, your passion and your excitement for this topic, and how Sarnia Lambton is in a very unique position, and was with the petrochemical industry because it started here, but we're also, because of the salt caverns and stuff, in a very interesting situation here. And I think the other thing too is why this is so important is that as we see the world decarbonize, we're seeing the turn down of our dear Chemical Valley. So we need to find, as they used to say, need to find another shtick. And I think this is it. And I think every way you think about this, what exactly you said to us makes sense. And I'm looking forward to following this. And I'm hoping sometime when we can get past COVID that you and I can sit down over a cup of coffee and talk about this. So that's thanks very much, Ed.
Thank you. It was all my pleasure.
Oh, and I guess I'm going to tell you, you can see on the screen, there's a certificate of appreciation for your talk today, and that will be sent out by Canada Post to downtown Brights Grove, where you reside.
Okay, Tropical Brights Grove. Thank you.